A glass flask contains some mercury at room temperature. It is found that at different temperature the volume of the air inside the flask remains the same. If the volume of the mercury in the flask is 300 centimeter cube, then volume of the flask is, okay, we have to find out the volume of the flask, okay. Coefficient of volumetric expansion, that is gamma of mercury, and coefficient of linear expansion, that is alpha, for glass is given over here, okay. Now let me assume that there is a flask over here which is made of glass, okay. It has a volume originally at room temperature, let it be equal to V0. At room temperature, let the volume over here of the mercury be equal to 300 centimeter cube, okay. It will be equal to 300 centimeter cube, okay. And the rest of the flask is covered with air, okay. Its volume will be equal to V0. Minus Vm, that is V0 minus 300. We will use this later, okay. When I heat this flask, both the flask as well as the mercury will expand. When the flask as well as the mercury expands, let the volume of the glass at that temperature be equal to Vt, and let the volume of the mercury be equal to Vm into T, okay. Let this be equal to V0 into T, let this be equal to Vm into T. But the volume of the air above remains same, okay. It means that the volume of the air is still equal to V0 minus Vm. So we will use this data in order to calculate the volume of the glass, okay. We will use this data in order to calculate the volume of the glass. First of all, we will use the volumetric expansion. In order to calculate the volume of the flask, okay. Now over here we can use the formula Vt will be equal to V0 1 plus gamma into delta T. This is for the glass, okay. Now let me substitute for the glass. The volume at T degrees Celsius, it will be equal to V0 into T. It will be equal to V0. The original volume I do not know the value. It will be equal to V0. Gamma for the glass, the coefficient of linear expansion over here is 9 into 10 raised to minus 6, okay. The coefficient of linear expansion over here is 9 into 10 raised to minus 6. So I can say that the volumetric expansion over here will be equal to, I can say alpha is equal to gamma divided by 3. So gamma will be equal to 3 alpha, which will be equal to 27 into 10 raised to minus 6, okay. So it will be equal to 27 into 10 raised to minus 6 into delta T, okay. Delta T is also unknown, okay. Similarly, if I want to find out the volume of the mercury at that temperature, it will be equal to Vm into T. It will be equal to Vm plus Vm. The volumetric expansion over here is given as, I can write this as 18 into 10 raised to minus 5 into delta T, okay. Now we have to find out the value of the expansion. We have to find out the original value of this part, okay. So in order to calculate the original value, I can say that when I subtract Vm, okay, when I subtract Vmt from V0 T, it will be equal to V0 T minus Vmt. It will be equal to V0 minus Vm, okay, plus V0 into 27 into 10 raised to minus 6 into delta T, okay, minus of Vm into 18 into 10 raised to minus 5 into delta T over here, okay. But it is given that V0 T minus Vmt is equal to V0 minus Vm, okay. It means that this value over here, V0 T minus Vmt, is equal to V0 minus Vm. So basically I can say that V0 into 27 into 10 raised to minus 6 into delta T will be equal to Vm into 18 into 10 raised to minus 5 into delta T. So basically delta T and delta T will get cancelled out. Vm, the volume of mercury over here, is given as 300 centimeter cube, okay. It will be equal to 300 centimeter cube into 18 into 10 raised to minus 5 V0 into 27 into 10 raised to minus 6. So over here 3, it will be equal to 3 9s are 9 2s are. So basically it will be equal to 2 into 10 raised to minus 3 into 10 raised to 6. So basically V naught will be equal to 2 into 10 raised to 3 centimeter cube. This is the volume of the cylinder, or the original volume of the cylinder, which is equal to option number C.